So today running samples for Chemco. Looks like cold rolled steel coming off a punch, so only single side is necessary. The top end is rolled anyway. We have sharp and burry edges, something that this machine can take very well care of. You have your brushes here, abrasive perpendicular with scotch brite in between, 60-40 blocks mix. As they go over the part, the front grinds right to left, then you have the same belt in the back, grinding left to right. So when the part goes through in a diagonal, we're getting action from both sides, and then we will hit all the edges. All we need to do here is very simple. Close up the machine. At that point, our warning light over here went off. This is what turns the grinding belt on. This is what turns the conveyor belt on. We pick our speeds. In steel, I would say we go 4 feet a minute. We can be a little bit more aggressive here. We are going up another 30 thousandths and full speed on the cross belt for the grinding action, because these are large parts that we hold. And we set our material thickness to 3 millimeter, and this is how we run. So turning the machine on. It doesn't matter where we go on the belt, because the belts go across, they will always wear evenly, so the abrasion consumption is always the same. What we are looking for when the part comes out in the back is the temperature, and of course what that sharp edge actually feels like. So here we have the part coming out. You see we have a very nice and round edge already, and that is at 4 feet a minute. And then all we are going to do with the other part, we are going to run it a little bit at a lower speed. You put here in the back of here, you also see the imprint of the part, which means we have been grinding, we have been creating some grinding debris. This is what you're looking for, and here is what you're looking at your edge. I think we're going to go a little bit slower. Like I say, this was 4 feet a minute. You get less on the inside contours than what you get on the outside contours. But even there, you can see the white line where you have, which is an indication of the size of your radius. So, all we are going to do for the rectangle now is we are going from 4 feet a minute to 3 feet a minute. All correction is speed. And again, always diagonal. And then the last part that you have here, we are going to run a scoop. And we will write that on the part so that you can see what that is. It's a very simple process, easy to handle, machine installed in about an hour, and you can train everybody how to use that machine in about an hour. And it's very easy to maintain. That's the key machine. In the back, you hook up the dust collector on the bottom. We have a very simple box type dust collector. Most of the time in this machine we sell a wet dust collector, because then you can mix aluminum and steel and stainless steel. So here now at the lower speed, and you will feel it when you get it, you have a rounder edge, and the radius of the edge depends of course on your punch quality also. Where you have tabs on the corner, of course that we cannot reach, that is still there. And you see on the surface, we remove very little surface, we just brighten it. And we have a good temperature in the part. And now for the last one, like I say, we will do actually 2 things. We'll go slower, we'll go 2 feet a minute, and we will go a little bit harder still. And you hear it in the sound that we are going harder now. And this way you have 3 different gauges of what you can do with the machine, and you can determine what kind of radius is acceptable for you. And of course, you want to go within that range of acceptability. You want to go as fast as you can, so you save abrasive and you reduce your throughput time. Here we're coming out. And this, of course, now the part is really warm. It is very warm, almost a little too warm, so I wouldn't recommend to go that hard. But now you're making a very smooth, round radius.